Hi everybody, today we're going to be looking at the trigonometry of acute triangles. So first things first, what's an acute triangle? Well, an acute triangle is a triangle where all three angles inside the triangle are less than 90 degrees. So here's an acute triangle here, ABC. Again, notice that our angles are uppercase capital letters and our sides are lowercase letters. The side labels also correspond to the angle labels by being across or opposite. How do we solve for problems when we are working with acute triangles? So there's two laws that we need to know. The first is the sine law. The sine law shown here, there's two different representations. Each is a ratio of the sine of the angle divided by the side, or the ratio of the side divided by the sine of the angle. Depending on what you're looking to solve for, a side or an angle, you want to use representation where the unknown is in the numerator. The other important thing to keep in mind is that we're never going to use all three ratios. We're always just going to use two of the ratios. So I'm going to look for one pair where I know both the angle and the corresponding side, and then one pair where I know either an angle or a side, and I'm looking to find the other. So when do I use the sine law? Well, there's two cases in which we can use the sine law. The first is when we have two sides and the angle opposite one of the sides. The second possible case to use sine law is when I have two angles and one side. Okay. What else can we use to solve triangles? Well, we can use the cosine law. Cosine law is shown here. Okay. Again, there's two different representations. So the first is when you're looking for a missing side. The other representation of cosine law is when we are looking for an angle. So similar to the sine law, when do we use cosine law? Well, we use cosine law when we are given two sides and the contained angle. It's also known as side angle side. The other time we use cosine law is when I have all three sides. If I have all three sides, I can use cosine law to find any of my missing angles. And once I found one of my missing angles, I can use either sine law or cosine law to finish solving the triangle. Okay, so in this example, we have two sides and one angle. The angle is not between our two sides, which tells us we're going to use the sine law. Okay, we're looking for angle theta there, and angle A, so we're going to use sine of A over A is equal to, I'm going to look for a set pair, which is B, sine of B over side B. Okay, and remember angles are uppercase, sides are lowercase. So the sine of theta over 3.1 is equal to the sine of 60 over 2.7. Okay, multiply both sides by 3.1 for us to start isolating theta. So the sine of theta will equal 3.1 times sine of 60 divided by 2.7. Last step to isolate theta, we do the inverse sine of that whole fraction. So it's inverse sine of 3.1 times sine of 60 divided by 2.7. Okay. Use our calculator, we calculate this, and we get that theta, or angle A, is equal to approximately 84 degrees. Okay. Now we can go ahead and find the next missing piece in this example. We can go ahead and find angle C. So I know two of the angles, so to find angle C, we're just going to do 180 minus those two angles. Okay. Again, remember, the sum of the interior angles of a triangle is 180 degrees. So to find angle C, we do 180 minus 60, angle B, minus 84, angle A, and we end up with 36 degrees. The last thing I need to solve for in this triangle is side C. Okay, again, I'm going to use my sine law. This time, though, because I'm looking for the side, I want that as my numerator. So I'm going to have C over the sine of C equals B over the sine of B. My next step, I sub in my knowns. So C over the sine of 36 degrees is equal to 2.7 over the sine of 60 degrees. Multiply both sides by sine 36, give me c is equal to 2.7 times the sine of 36 degrees divided by the sine of 60 degrees. Use our calculator, and we get an approximate value for c of 1.8 centimeters. So my triangle is solved. I found every angle and every missing side. In my second example, we're looking to find all three missing angles in triangle ABC. So given that I have all three sides, I know that I'm going to be using the cosine law in this example. Okay? To find angle A using the cosine law, I'll use the representation of the inverse cosine of b squared plus c squared minus a squared over 2bc and close my bracket. Okay. My next step, I'm going to sub in the known values, which are all my sides. So angle A is equal to the inverse cosine of 2.9 squared plus 3.0 squared minus 2.0 squared. All of this over 2 times 2.9 times 3.0. We now simplify inside the brackets. I evaluate all my exponents and add my numerator, and I get a value of 13.41 over 17.4. Last step is to evaluate this in a calculator, and I get that angle A is approximately 40 degrees. I can now go and find a second angle in this triangle. To do that, I'm going to use sine law. So the sine of angle B over side B is equal to the sine of angle A over side A. We sub in what we know. So I don't know angle B at this point, but I know that side B is 2.9. Okay. Angle A, I just calculated as 40 degrees. Side A is equal to 2.0. Multiply both sides by 2.9 to isolate sine B. So I have 2.9 times the sine of 40 degrees divided by 2.0. And then my last step is to take the inverse sine to find angle B. So angle B is equal to the inverse sine of 2.9 times the sine of 40 degrees divided by 2.0. We can evaluate that in our calculator, and we get that angle B is equal to approximately 69 degrees. So now I know two of the angles in my triangle. I'm just missing angle C. So angle C is equal to 180 degrees minus the other two angles. So 180 minus 40 minus 69. And I get a value for angle C of 71 degrees. So in the third example, I have a triangle. I know two sides and the angle between them. So when that's the case, I'm going to use cosine law. Okay. Again, with cosine law, it's written as ABC as our variables, but we can use it with any three letters. So I'm looking for side E to start. So E squared will equal D squared plus F squared minus 2 times D times F times the cosine of angle E. Sorry. Okay. Our next step, we sub in what we know. So E squared will equal D, which is 11 squared, plus F, which is 13 squared, minus 2 times 11 times 13 times the cosine of 75 degrees. Okay. So in this step, we're going to start evaluating. So E squared will equal 121 plus 169 minus 74.0168. Okay, Again, this is an approximate value as we've evaluated our cosine. We want to keep 4 decimal places anytime we evaluate one of our trig ratios. Okay, we simplify these just by adding and subtracting, and we end up with e squared equals approximately 215.9832. And the last step is to take the root to determine what the value of e is approximately. Okay, we do that, we get an approximate value for e of 14.7 centimeters. Okay, I now have all 3 sides in one angle, so I'm going to find my second angle using sine law. Okay, so the sine of angle D over side D is equal to the sine of angle E over side E. Okay, we sum in what we know, so the sine of angle D divided by 11 is equal to the sine of 75 degrees divided by 14.7. Okay, I multiply by 11 in my process of isolating for angle D. So 11 times the sine of 75 divided by 14.7 sine D. And my last step to get angle D is we do the inverse sine of 11 times sine 75 divided by 14.7. I do all of this in my calculator, and I get a value for angle D, don't forget your angle markers, of approximately 46 degrees. I now have 2 of my angles, so to find a third angle, angle F, I'm just going to do 180 minus the other 2 angles. So 180 minus 75 minus 46, and I get a value for angle F of 59 degrees. So there's my solved triangle. I found the missing side and the 2 missing angles. So in this example, I have 2 angles and 1 side. The first thing you'll notice is there's no labels in this triangle, so we want to go ahead and label this triangle as ABC. Okay, now I can find the missing angle, angle B, quite easy as I know 2 angles. So 180 minus 48 degrees minus 44 degrees gives me an angle measure for angle B of 88 degrees. So I now know 3 angles and 1 side, so I can find my 2 missing sides using the sine law. Okay, I'm going to start with finding side A, so A over sine A will equal B over sine B, as that is my complete pair. Okay, so A over the sine of 48 degrees is going to equal 12.8 divided by the sine of 88 degrees. I multiply both sides by the sine of 48 to isolate for A, so A will equal 12.8 times sine 48 over the sine of 88 degrees. Then I can evaluate that using my calculator, and I get that an approximate value for A of 9.5 meters. I can now go and find side C doing the same process. So side C over the sine of angle C equals side B over the sine of angle B. Sub in my known values, so C over the sine of 44 degrees equals 12.8 over the sine of 88 degrees. Isolate C by multiplying by the sine of 44, so C equals 12.8 times the sine of 44 over the sine of 88 degrees. And evaluate that in our calculators, give me an approximate value for C of 8.9 meters.